Hey everyone, my name is Michael from Everything Astronomy, and welcome back to our third and final podcast episode with Professor Meyer from the University of Michigan. Hope you enjoy.
Right. And then so once things are prioritized, obviously, a lot of astronomers are going to need to go to like observatory facilities and schedule telescope times. I know the University of Michigan offers a spring course that allows us to go to Kitt Peak National Observatory and have some time with the telescopes there. But would you care to go into the logistics of how, without those kind of special opportunities, how most researchers apply for telescope time and how all of those processes work to actually get the data?
Sure. And I can say that it's true for getting funding for research, it's true for proposing new instrumentation, and it's true for getting telescope time, is that these are all oversubscribed quantities by factors of a few to factors of a dozen or more, 12 to 1, 20 to 1 chance.
Mm-hmm.
So we write proposals. And again, we're given guidelines. You need to address these elements to it. You need to show how your work or your observing can really make an impact in the field. And then we submit these proposals, and then there's a committee that's chosen, which rotates every year. It can be slightly different, that evaluates these proposals and tries to assign time on the basis of the technical feasibility of the program, the quality of the science, the confidence that the research can get done, and the impact that that research would make on all of astronomy. And so a working professional astronomer has to get good at writing proposals. Otherwise, you can't get telescope time, you cannot get computational time on supercomputers, and you cannot get research funding to do the work that you want to do. So it's peer-reviewed, competitive proposals. They're generally anonymous reviews. We are now moving to a place in our field where double blind is more common,
Mm-hmm.
where not even my identity as a proposer is revealed. With all academic pursuits, I think there is a tendency towards conservatism and playing it safe and going with what you know. And in fields where there are large, important, underrepresented populations, those mechanisms can tend to make the rich richer and the poor poorer. And so if there's some 60-year-old guy who just has always gotten 10-meter telescope time and just keeps
Mm-hmm.
getting it, that makes it easier for them to write better proposals. And then that person's name and you think, oh, wow, so-and-so is
Right.
really a great astrophysicist and will do a great job. And so I'm just going to give the time to them and I won't even read their proposal that carefully. Well, it's really hard for a younger person or women or people of color to participate and to compete equally on a playing field like that. So one thing the Hubble Space Telescope pioneered in their proposal allocation was to make it blind so that you would not know who I was if I was proposing to you. And it's a double blind. I don't know who the reviewers are. They don't know who the proposers are until after the grading is done. And we saw in a few experiments with this that actually made the successful proposal group much more diverse than the previous versions. And so this is now getting to be a norm in the field. More and more competitive things are moving towards that double-blind procedure. So that's a really positive element.
And now with COVID-19 and this disruption it's caused not only on astronomy, but science in general, how does this change the proposal process, and how does this change going forward after the decadal survey and our outlook in astronomy? Now that we're kind of delayed, are people who have telescope time reserved for the next few months told no, they can't get it and they have to reapply next year? Does this make it more competitive in the upcoming years? And have you directly been affected in terms of getting telescope time?
Well, as with everything, we are all affected. Our observatories have been shut down for months, all of them, all over the world. The Michigan access to things at Kitt Peak is shut down. The Michigan part of access to the Magellan Observatory has been shut down. The European Southern Observatory has been shut down. Everybody's shut down. We still don't, I had telescope time. We had 2 observing runs planned for April and May. They were both basically canceled. I might find out today that one of my graduate students still gets a little bit of time in late May or June, not even on the instrument he wanted to use. So it's kind of like a total backup project. So everything is just completely chaos and unprecedented shutdown right now.
Right.
So sort of as they reopen the observatories in the next few months, kind of random things will be getting done because none of the instruments that were planned are on the telescope. And so you're really playing catch up. We're in the process of reviewing proposals for the next term in the fall and winter. We hope things will be back to normal at the observatory. We have confidence, and it's reasonable to expect that they might be and will remain that way for a while. So I think going forward, at least the telescope time access will come back to normal. It might be much more common to do service observing or to send one group of people to do observing for a large number of different programs. Astronomers, particularly at Magellan, it's a little bit old-fashioned, and people like to go down there and take their data themselves. And I'm among them. I would love to be there and do it, but I also recognize that it's much more cost-effective than to fly all these people all around. And sometimes even a technician who's not the expert on the observing program knows how the instrument works better than the random person from one of the 8 institutions that wants to go down there. So there are good reasons why service observing or queue scheduling or remote observing are better. Anyway, so we'll get back to normal on that front. Right now, all proposal reviews that are in process for funding for the next years are being done remotely. That's different than having a panel meet face-to-face, but I don't think fundamentally so. So I think what we'll even find in the next several years is that we'll probably be doing a lot less professional travel. Not just even so much because it's so dangerous, but because it's just really not necessary. Right. There is value added to being in person, but it's maybe a 10 or 20% value. And the extra cost, and frankly, I've been worried about this the last couple of years, even though I haven't really curtailed my professional travel. It's one of the worst things that I personally do to the environment is to fly in an airplane. Right. Compared to my recycling, milk canisters and things like that. Me taking, 20 flights per year internationally, that's really terrible for the environment. And so I should think more broadly about my impact of my work life. And I think we have realized, even though these Zoom and Blue Jeans and video conferencing are not ideal, they are good enough to save some of the work travel. So we'll probably be decreasing that. As far as the future of the execution of the decadal survey and what's going to happen, honestly, we don't know. I think none of us know what's going to happen to the economy and how government funding will be affected. My own personal experience when I was in Arizona and transitioning to Switzerland during the Great Recession between 28 and 2010 was very dramatic. The University of Arizona suffered a lot during that economic crisis. I think Michigan is probably in a somewhat better business model or financial model to most state universities, so they will do better than most. But we have taken a very, very serious hit. I think it's really, really hard to say. None of us know how this is going to affect the economy in the long term. And something else I tell my students and postdocs that you haven't lived through yet, but in my professional life, when I started applying for grad schools in 1991, we were in the middle of a recession. And one of my advisors told me I absolutely should not go into astronomy. It's just so terrible, and through financial crisis, nothing will get funded, and you're really taking a risk you can't justify. Things will go up and they will come down at frequencies and durations that is very difficult to predict over your professional life. So I also have to say, I think we are facing a new reality in terms of priorities for our culture and our society and us personally. And so who knows what the future is going to look like. I think there will be efforts made to stimulate the economy, the good efforts made with good intention. I think in some cases, the work that we do in astrophysics intersects with certain industries like aerospace industry and space industry. And some of those injections of funds will mean that it's easier maybe even to get certain kinds of projects going related to the aerospace and space industries and other kinds of technology programs that do interface with astronomy and astrophysics. So those might benefit, surprisingly, or in the near to midterm, and other things will probably get delayed. One of the projects that's on the horizon for many of us in astronomy are the ground-based construction of extremely large telescopes with diameters between 25 and 39 meters, which are really the future of ground-based astronomy. we expect delays, but we don't expect that those are going to go belly up.
Right.
We're very excited about those capabilities in the future, but there will need to be a balance between what we need to do as a society and as a population, as humanity, to make sure that we take care of each other during this time.
Yeah, and I know all of these stay-at-home orders are really bringing an emphasis on a lot of medical research, and that people are going to want a lot of funding into cures and disease prevention. So I guess a thought in the back of people's minds would be then, how would astronomy then affect the medical and disease prevention, and also affect the big vision that we're seeing on climate change? How would astronomy change how we understand our own planet's climate, now that everyone has been staying inside, and we can see that there's been a lot of improvements, like dolphins returning to Venice and different things as such. So I guess a lot of people will be questioning why we would keep putting money into astronomy, considering that one disease could cause this much chaos, and that we should probably put more money into medicine.
Well, I have to say I can't deny that I wish we were funding our biomedical research infrastructure at a higher level right now. Yeah. And if we're going to talk about Apollo programs, boy, I'd sure like to see an Apollo era investment in vaccines for COVID-19.
Right, but I know you mentioned like studying different planets could help us understand our own. So
yeah, well, and even beyond that, I think, and I'll come to that in a second, I think the detector technologies that we work with can have biomedical applications. Mm-hmm. And related to that, the software development and the algorithm development that we do for image processing turns out to be a huge part of magnetic resonance imaging and looking for tumors in people's brains and things like that. So there's a lot of overlap between medical imaging and astronomical image processing that's extremely practical. Mm-hmm. Not to mention the energy in big data and machine learning, that where astronomy is really at the forefront. I think there will be a lot of unintended benefits from the kinds of research that we're doing. I tried to mention before, there is a lot of real interest in keeping some of our big manufacturing and high-tech industries going, and that will be part of it too. But I also do believe that the kinds of work that we're doing in the most basic astronomy research, such as searching for, finding, and characterizing exoplanets, could have long-term benefits. And one of the things that I like to emphasize is that atmospheric chemistry and the diversity of planetary atmospheres is bewildering. We see iron sulfide clouds and rainout on exoplanet atmospheres. Mm-hmm. We find variations in the carbon to nitrogen to oxygen ratio that we couldn't fathom before. And I think what we'll find in the next 10 to 15 years, even if we're trying to look for life and don't find it, I think we will find a diversity of complicated exoplanet atmospheres, which will hopefully, there will be some understanding of the patterns in those data, which I akin to understanding climate as opposed to studying the weather, which is sort of chaotic and complicated. And if we can find patterns emerging in atmospheres of other worlds in very extreme end member cases of the kinds of atmospheric physics we study, maybe we'll even find some unique insights into how our own planet and atmosphere has evolved and what we can do to help it heal itself over time.
So, Professor Meyer, you mentioned that that we can learn things from other planets. I guess where I'm going with that is, it might seem a little bit fantastical to many people to think that a planet where there's iron clouds and things like that. I think it might seem a bit fantastical to some people, and it doesn't really seem like there could be an earthly application to just knowing the fact that there are things like that exist out there. So, for example, how would knowing something like that help, everyone, the global community, deal with the problem of climate change that we have now?
I'm not an expert in atmospheric chemistry and dynamics, so I can only outline in broad brush what I'm trying to get at. But suppose that under very specific temperature and pressure conditions and at certain concentrations of certain kinds of chemicals, a new series of chemical reactions is initiated, and the agent that ultimately changes the composition of the atmosphere does not immediately present itself until 3 steps into the chain of those reactions. Maybe such a process could be even discovered and understood in an incredible, weird alien world atmosphere. But the idea of discovering that process, which we might then call the, Ann Arbor process, is discovered. And that same kind of process could be realized under incredibly different temperatures and pressures and with different molar concentrations of other species. But the process itself could still happen in a different context that might lead to real changes in a more Earth analog atmosphere. You could imagine connections like that being made. And that the simple, we can't create everything in our laboratories. And so going out into the universe and finding extrema is sometimes a really good way of learning what's possible, which we can then adapt and change to understand things that are more terrestrial to us.
Cool. Thank you.
Yeah, but unfortunately, COVID-19 has kind of locked us all inside, and those wonderful discoveries, like you mentioned, have all been put on hold. So in the meantime, I know a lot of people have been turning to the fantastical, especially with this video of a supposed UFO that the Pentagon has released. We know that you haven't seen it yet, so I'm going to pull it up for you, and then we'd like to get your thoughts and kind of your first initial reaction to what this may be, if you think life could become this intelligent without us knowing, and the things that a lot of science fiction is based off of. I'll get this here for you.
Yeah, and I guess just to narrate over to the people who are listening to this instead of viewing the actual video, we're just viewing a Pentagon video that was released in mid to late April, I believe, from I think 2005. One of the videos was, and also the other one was, 2 of them were from 2014 or 2015, and it just depicts your usual, UFO video, some unidentified object flying over water or land.
Yeah, so I believe this was some Navy training exercises, and then they picked up on these different objects that they have confirmed that they still don't know what they are.
Okay, so it looks like a potato. I don't know how big it is. Is it
Right?
Is there a scale? Do they report a scale anywhere on how big it is?
They did not, but they did report that it was flying at around Mach 0.55.
Yeah,
which
it looks like 120 knots is the wind, and then it's keeping up with them at supersonic speeds in their jets.
And I think one of the fantastic things with this video that's come out is that, and I mean, this has gone around. I've heard so many people talk about this, even in my friends, even my family, the internet. I've seen this video a little bit everywhere, and I think what's quite amazing is that when we consider how large space is, and that we've never really even come close to finding anything scientific, anything rigorous about aliens, there's been, and I think this might be throughout time, we've had all of these little inklings that this could be something that is perhaps cannot be explained by our earthly means yet. And so we turn to just speculating that it's just aliens out there doing this. But I mean, I think this, and that to me is more in the realm. And I mean, we talked with you earlier on, and you talked about this too, how this is just more exploration and potentially even wild speculation than rigorous science. But I think it does captivate the imagination. And I was wondering what your thoughts were on these kind of things. We have gotten signals from outer space that cannot really be explained, like the WOW signal. We now have these videos. I know there's other little things that exist out there that cannot really be explained. So what are your thoughts on that as a person who is doing a science so closely related to potentially astrobiology? What are your thoughts on aliens, if we can put it like that?
So I am not impressed with that video. I mean, I would love, when I was a kid, after I saw the first Star Wars movie, I just dreamed every night that somebody would just swoop down and pick me up off of my, dead end street and take me up into the stars. So I get it. I would love to meet aliens. Although now that I'm 53 and have kids, I would be super terrified of,
right.
If that's an alien, I mean, I'm going to go off the grid or something. There are so many other ways to explain everything that I have seen, including the wow signal. For those of you who want to research it in the radio astronomy literature, it is curious, but there are still sort of several viable alternative hypotheses. And I guess for me, and there I'm thinking, wow, how many countries have enough money and tech to do something like that, and they wouldn't tell you they were going to do it?
Right.
I guess at least dozens. Probably not hundreds, but surely dozens.
Mm-hmm.
And I guess my cynicism is that I'm pretty sure that they wouldn't tell me they were going to do that. And I could easily imagine there being an unrecorded test of some sort by some other government. And
I mean, I learned through researching a little bit about this video that when the SR-71 Blackbird was being tested at the time, back at Area 51, or Area 51, apparently the number of reported UFO sightings dramatically increased because people were seeing the plane reflect the sun as the sun was in the night sky. And so, I mean, it is obviously much more plausible that these videos and all of these things would just be from any other man-made creation. But I guess, do you expect that aliens are out there? Do you expect they would try to be contacting us? Do you think that we as humans should try to contact them? I know this is completely out of the realm of science, but.
Yeah, so first of all, I spent 5 years as a deputy principal investigator for a node of the NASA Astrobiology Institute. And I learned a ton about the biochemical origins of life in talking to biologists and people who study that. But the one thing I learned is that we have no viable theory for the biochemical origins of life. It is a miracle, a twin miracle. And I use that in the scientific sense of being able to have a membrane gather around genetic material that's capable of reproducing itself and a chemical engine that can extract energy from its environment, so-called metabolism. And there are many ways to do it. It's not beyond the realm of science, but we don't know exactly how it happened on Earth. We have a lot of theories about how it could happen. But I guess my feeling is that the emergence of life in the universe is probably very common. But if you talk to evolutionary biologists, they also diverge wildly on how likely it is that intelligence, such as we call ourselves intelligent, is a natural outcome of evolution, or whether the ants are going to be here when we're long gone. So if you ask me like a Drake equation or a Fermi paradox, I don't think there is a Fermi paradox. I think we have absolutely no idea how likely it is that intelligent life could exist in the universe. And the universe is awfully big, and it lasts for a very long time. But I am not at all surprised we have not been contacted. I think the chances of us finding life elsewhere in the universe are very high. But I have absolutely zero idea whether intelligent life is common or rare. Zero. Right. And anything else is just me, what are the Minnesota Twins going to do 5 years from now? I don't know. You want me to talk about it? Sure. If I had nothing better to do, I'd talk about it. But given that I think I do, I kind of find it uninteresting to speculate. I even apply this to the sort of higher order terms in the Drake equation. How long do technological civilizations live? I don't know. I have no idea. I have absolutely no idea. So I tell people I'm absolutely convinced there's life elsewhere in the universe, and I have zero opinion on whether there's intelligent life elsewhere. by many orders of magnitude.
Right. Like statistically speaking, like there's no way that given the observable universe that we're the only form of life, whether intelligent or not, let alone speculations that the actual universe is anywhere between 250 to 10 to the power of 53 times bigger than the universe that we can see. So I feel like, I'd have to agree that there's life there, but focuses should be not on whether or not it's intelligent, just how it evolves and how we can take away from that to improve what's going on here on Earth.
Finding life elsewhere, I think, well, number one, if I were starting over, I might get interested in biochemistry because I think it's just super fascinating. There are many different ways to construct a genetic code. There are many different ways. I mean, the origin of life is amazing, and there's a wonderful research going on in that right now. I think we don't know how to look for life. I don't think we will recognize it when we see it. I think looking for life in the universe right now is exploration, and that's a good thing to do with one's time. But to me right now, it's not quite yet science. And the reason I say that is what I came back to before. I think even harder than proving that you found life will be ruling out that there's life on something you looked at and didn't see anything that suggested life to you. Mm-hmm. So you're not going to know there's not life there. So what even is the experiment? Is it an upper limit? Is it a lower limit? What on earth am I doing? Right now I'm just looking, and I'm going to try to see what's out there. But for me, that's not science. That's exploration, which is a great thing.
Mm-hmm.
Yeah, I think it's interesting how I would say for myself as well, when I was a kid, what first got me interested in astronomy wasn't the science. It was more the explorative side, or asking about alien life, watching science fiction movies, stuff like that. And it's interesting to see how, over the course of your career, over the course of education, it's changed. Where when you were a kid, you mentioned you were watching Cosmos, and at the end, Carl Sagan talks about alien life, talks about other worlds and how life may be different. But now after kind of being exposed to the science and the rigorous hypothesis testing, you're saying it's not even a question that should be asked yet. It's still exploration. So I think that's
but finding life either elsewhere in the solar system that we could prove that was diverse from the one that started here, that's to me the science discovery of the century. Because proving that it arose twice, that would fill me with such optimism. It can happen. It wasn't just a one-off. And if I find that on a nearby star, I mean, that's even better. It's just amazing. And so I guess while I'm not expecting to get up in the Millennium Falcon and help defend it, I'm now even more excited about the prospect of just that philosophical question, that life has arisen independently multiple times. And frankly, we might even discover that on Earth. Maybe we're coexisting with biota we haven't recognized yet. Mm-hmm. Do we know how smart encephalopods are? I don't really think so, but I'm really thinking that we're underestimating most of the cognitive abilities of the species on this planet already. My dog is a lot smarter than I give her credit for, to be honest. So I think we still have a lot to learn about our own biosphere. In addition to trying to explore others. I'm all for that. Mm-hmm. I'm sorry to interject, but guys, I actually have to go. I have another meeting that I'm already late for.
We were going to thank you for coming on, and I think that was extremely interesting. We got to explore so many different topics with you and get your thoughts and ideas on a wide variety of things, both scientific and slightly less borderline not at all scientific. But thank you very much for coming on to our podcast, and
thank you so much,
have a good
Professor
day.
Meyer. Yeah.
Thank you so
much.
Take care, guys.